This is what everyone sees as a substation transformer. It's a tank filled with mineral oil. Inside that tank, there's core steel. If you look at the piece that looks like an M, that's a specially grained steel. And that is what causes all the delays in transformers. That steel is hard to come by. And in our case, on the rebuilt transformer, we believe that steel is in good shape. On the type of failure we had on our transformer, we believe it's based on the coil of the transformer, not the steel. So this is a substation transformer, three-phase steel core that's put together, and it's literally a piece of steel, a space piece of steel. Around that core, they ran copper. Copper is fairly easy to get a hold of, so that doesn't cause delay. Now, another component of the inside the transformer is a paper. There's a cellulose component to the paper that you can test in oil sample to see if your paper is going bad. But what we feel happened with our transformer, specifically at Port Ludlow, is the winding shorted out. The windings will short between the gaps on the transformer core itself. So they'll be short across. This transformer did short in 2012, right before we purchased the system. A lot of times a small short will burn itself clear. And then if you monitor it and do certain things, the oil will clean itself out. In the case of our failure, it was catastrophic. And in a catastrophic failure that we had, this is the oil samples. And a lot of times what you're really looking at is your acetylene levels. And the settling is caused by arcing between the two copper wires, and it builds up acetylene, ethylene, and methane. Based on this, we're very comfortable that our fault was due to a winding failure, which means our core steel is good. So that's one of the reasons we're recommending to send it off to be rebuilt. They will reuse the core steel, they will reuse the tank, and they will basically rewrap the core steel with the copper so it looks very similar, and then move that transformer forward. That was real quick understanding of the transformer. All of this, the mineral oil is the insulation. And the reason the mineral oil is there is so that the outside tank can be built smaller. It does insulate it so that you don't need as much air gap if it was a dry pack type transformer. We do have one company that has come back with some close dollars. Until they actually pull it apart, they'll give us estimates. Their estimate is right at 400,000. It's a pinch over. We are talking to two other manufacturers that do rebuilds. We will take their numbers and then be able to ship the transformer off. Shipment right now has tripled. We originally thought, in the 2 years ago, shipment would be 5,000. We were told estimate 20 for the shipment one way. We're probably going to pay 30 to ship it one way and then back. So those costs, the shipping continues to go up. Worst case scenario, let's say, is we would pay for the shipment and the detanking of the transformer. Literally, they cut the top off, pull it out, and then they can find it. So that much we would have out. At that point, we would say, no, there's too much damage. It's not worth another 200,000. At that point, the manufacturer or the remanufacturer we send it to, they'll give us credit for the copper and the steel and the tank. And we won't recoup all of our costs, but we'll recoup a good portion of them. And a lot of times, then they will go ahead and rebuild it on their own and sell it as a rebuild. But in our case, we would be out a little bit of money, but not a ton. And the goal with the rebuild would then go back to Port Ludlow. It would be a new bay at Port Ludlow, so you'd have a brand new one and the rebuilt one. So that if anything failed, you could fail over. And a couple of the new circuits we're talking about coming out of Port Ludlow substation would be off of the rebuilt transformer. We're reviewing our design right now of what we bought in the past. We believe we're going to go with a little different type of transformer. We're hoping that we have the new specification out to bid by the middle of April. And then it'll be a 2-year time frame after that. Part of our decision too has to be, if we send off this to be rebuilt, I can get it in a year. If I purchase a new, it is 2 years out. So there are other ways to buy a used transformer, maybe a little quicker. Now, we have looked for years on the used market, and because of the type of transformer PSE uses, the YY Delta, it's very difficult to find a match at our voltage. It's extremely hard. And we do look. If we would find one, we would bring it back to the board, but they're just not out.
So looking forward, not knowing for sure what growth in the county will look like and things like that, are we looking at larger capacity transformers or changing the grid incrementally, or could you give us some inclination into how we're determining what size we need?
Right now, the transformer specifically that we're going to purchase, the new one, will be for the Quilcene area. For today, that's where the design will go. We are replacing that with a 20 MVA transformer. We have 20s now in all of our substations except Quilcene, which is a 5, and Chimicum, which is a 25. I believe our overall engineering goals will be to put 2 transformers side by side per substation, so that if you have a failure, you can automatically switch over to the new substation or the new transformer.
So you're making them interchangeable.
They not only interchangeable, but they could be ran together or they could pick up the load of the other one. If you go with that philosophy, we don't need to buy 25 MVA transformers. We're better off to go with 2 20s than we are with the larger transformer. Our estimate, it's going to save us at least $300,000 to rebuild it than it is to buy a new one. So at that price, I believe it is worth having it rebuilt.
Thank you. Kevin, I appreciate your creativity as always in trying to find the best deal for Jefferson County residents. I appreciate the photos and the explanation of how these things work. And I think it makes a lot of sense to, if this thing's not precious metal, but hard to get metal. I think your assumptions are good of what's happening in there. And I really appreciate also that you're taking a long-term view of trying to standardize the equipment in our substations and make us more resilient so that in the future we'll have more flexibility to deal with growth and more ability to deal with failures when they happen. So this all sounds like a great plan.